Welcome to lesson 5, quadratic functions. So in this lesson, we're going to learn how to solve quadratic equations by a number of methods. Excuse me. Make sure that we're using the most efficient method and not just stuck doing it one way. And then we're going to talk about graphing quadratic functions. So it will help us to know what a quadratic function or a quadratic equation is. So a quadratic equation in X is an equation that can be written in this general form. And the general form would be ax squared plus bx plus c equals 0. So at this point, it's written as an equation and not a function. It would just be equals f of x if it was a function. Right? And this is where a, b, and c are all just numbers. And the main categorization that matters is that a is not 0. In other words, there has to be the squared term. That's what makes something quadratic. Remember, when we didn't have that term and it was just bx plus c, that was linear. But having the quadratic term is what makes, the x squared term is what makes something quadratic. So there are a number of ways that we can solve a quadratic equation. And so we're going to go through all of them. And then we're going to talk a little bit about what is the most efficient method of solving a quadratic equation. So in the first way, we're going to use our factoring that we learned in one of the previous lessons, the last lesson, I believe. And to apply that factoring, we're going to use this thing called the zero product principle. You don't need to know its name, but you just need to know kind of the logic behind it. It makes a lot of common sense. So it tells us that if a times b equals zero, in other words, two things multiplied together is 0, then guess what? One or the other of those two things has to be 0, right? There's no way to multiply together two numbers that are not 0 and get 0. Okay? So a and b could be variables, they could be binomials, they could be things that have a lot of terms. It doesn't matter what a and b are. If you multiply two things and you get 0, then one or the other is 0. Here's how we're going to use that. We're basically going to factor an equation, and we'll have these two factors multiplied together equaling 0. And so then we'll say, well, either the first factor has to be 0 or the next factor has to be 0. So that will allow us to solve. So let's look at the steps here. As a pre-step, as a setup, make sure that you've simplified everything first. I think most of our equations come simplified, but just in case, like, your like terms are combined and that kind of thing. So step 1, 0 has to be by itself. This is not the for product principle. This does not work if it says AB equals 4, then A is 4 or B is 4. Nope, that's not true. It only works for if everything is equal to 0. So you have to get everything on one side, 0 on the other. In terms of factoring, we generally want the x squared term to be positive. This just makes factoring easier. Once you've gotten 0 on one side and everything else on the other side, you're going to factor your quadratic, your equation completely. Okay, factor out a GCF, etc. Then we'll apply the zero product principle. And the way we do this is we basically just set each factor equal to 0. Since the 2 or 3 of them multiplied together equals 0, each one could be equal to 0, and then we solve. Okay. So not too difficult as long as factoring has gone okay for you. Let's go ahead and try the first example here. So you'll notice that I do not have everything on one side and 0 on the other. So I'm going to move this 5 over to the other side via subtraction. And now I do have everything on one side and 0 on the other. Now we're going to need to factor this. This is generally an AC method problem if you were doing your AC method. So I'm going to factor in my head because at a certain point, and you may not be there yet, but at a certain point, you do want to be able, especially ones with small numbers like these, to kind of think about being able to factor it without having to go through that whole AC method process. But if you need the moment to do the AC method, like I said, hit pause, do it, and then come back, okay? I'm just looking at, I know it's got to be 2x and x. It's the only way to get x. This is a 5, so it has to be 5 and 1. The reason I'm going to put the 5 over here is because 2x times 5 is going to give me 10, and x times 1 is going to give me 1, and I'm trying to get a -9 in the middle. So I can see that I'm going to need a 10 and a 1. How am I going to combine those? Well, since this is a -9, the 10 needs to be negative and the 1 needs to be positive. So then what I do is just a quick check in my head. This would be 2x squared plus x minus 10x. That gives me minus 9x and minus 5. So that's an example of, I'm not really guessing and checking. It's just that I've done so many factoring and multiplying problems that I have an intuition about how this thing needs to work out. But AC method works just as well. So now I'm going to apply my zero product property. This times this is 0. So either this is 0 or this is 0. So what I'm going to do is set 2x plus 1 equal to 0 and solve that, and x minus 5 equal to 0 and solve that. So I have an x equals -1/2 as one answer, and an x equals 5 as a second answer. Okay, that's it. That's the solved by factoring in a nutshell. So let's try another one. Same thing on this second problem. I do not have everything on one side and 0 on the other. I see that I currently have the x squared term as a negative. So it's probably going to be easiest to factor if I add the 3x squared over to the left side. Okay. And now that is ready for factoring. So however you need to factor that, if you want to use the AC method, that's fine. If you want to try that method I was talking about in the last example, so you can reason through 3x and 2. In order to make this a +5, I need a +6 and a -1. I'm just going to quickly double check that. 3x squared minus 1x plus 6x is plus 5x. -1 times 2 is -2. And then since it's already two things multiplied equals 0, I will set each one equal to 0. And now I have my two answers. So solving by factoring is pretty efficient as long as your factoring is solid. So you can use also this thing called the square root property. And the square root property is pretty handy, but it only is handy in certain situations. Your equation has to be in a particular form in order for the square root property to work. And the square root property basically just tells us that if you start with x squared equals a number, then x will be equal to either the positive, well, to both the positive and negative square roots of that number. That's what the square root property tells you. So a really basic example of that would be like x squared equals 4. Then x is either positive or -2. You do need both in this case because x squared equals 4 means that I can have either the positive or the negative. So we kind of write that as plus minus the square root of whatever number is on that side. So in order to apply this, you really need your equation to be either in x squared equals a number form, or maybe it's in a something squared equals a number. Maybe it's more than just x, but that whole thing is being squared. So just for context, if I look down here at my examples, they don't look like they're currently in that form, but you notice I don't have an x term. So I could move this 8 over and divide by 3, and then I would have x squared equals a number. In fact, I'm just going to do that so you can kind of see. Divide by 3, 48 divided by 3, I'm pretty sure that's 16, 32, yeah. So now I have it in that form. And the way I was kind of able to tell I could do that is because there was no x term. Okay. Or same thing here, I have this part B, I have this thing being squared, but everything else in my problem is just a number. So if I add the 1 over and divide by 2, You see how once again, I have it in something squared equals a number form, right? So I can get the thing that's being squared isolated first, and then I'm going to utilize this property that says when I take the square root of both sides, I need to make sure I keep plus minus in front of the number side so that I have both of my possible solutions. So that would be plus minus 4 on the left. When I do it over here, I'm going to have an extra solve step because I'll have just x minus 1, the square root and the squared will cancel. But then I also have plus or minus square root of 15 here, and I don't have the x by itself. So I need to add 1 to the other side first. I can't actually add 1 to a square root, so we just write it like this. Right? 1 plus or minus the square root of 15. So the two answers there is 1 plus root 15 and 1 minus root 15. But we write them sort of compactly like this. If I could simplify the square root of 15, I should. That's why we did that prerequisite skills on simplifying square roots. But in this case, there is no perfect square that goes into 15. So we're not going to end up needing to simplify it. So I just did both my examples, and I kind of didn't finish going through the wordage, the verbiage here, the explanation, isolating the thing that's being squared on both sides, if you need to, isolating it, and then square root both sides. Be sure to include the positive, negative. Okay. The only difference is when you have something else squared, you have that extra step down here where you have to actually get the x by itself, right? Had to add the 1 over. So that's solving using the square root property. It's short and quick, but it only works if you have your equation in one of these forms, or it could be written in one of those forms. And the not having an x term is the indication that you can do that. Last but not least is our solving a quadratic equation using the quadratic formula. Okay. So there is a formula that you can use as long as you start with this general form. So you'll notice, again, it's everything on one side, 0 on the other. If you try to apply this formula and you don't have it in that form, it will not be correct. You'll have mismatched signs for A, B, and C. So in this case, once it's in this form, the A is the number in front of the x squared, the B is the number in front of the x, and the C is the constant. You can plug them into this formula, and that will give you the solutions. Now, I know the formula is kind of complicated looking, but it is a formula that follows you everywhere. You will use it throughout the rest of your math career. So you do need to have this formula memorized. Okay. Tips for success. Here is what we need to do in order to make sure you're going to do this correctly. So I already said, make sure it's equal to 0 before you write down what A, B, and C are. Then you're going to plug those in, and you want to simplify the number under the square root first. So start by simplifying here. Then, if you can, simplify that square root. And lastly, if you can, factor a GCF out of the numerator to simplify with the denominator. So I'm going to do just a couple of examples here, or one example here, and you can kind of see that process in action. We have this equation here, 2x squared equals 6x minus 1. So you might notice from the beginning that I do not have all of the terms on one side and 0 on the other. That is our first step. You need to make sure that everything's over here and it's equal to 0. So we're going to go ahead and move the 6x over and the 1 over by subtraction and addition, I guess. So we'd have 2x squared minus 6x plus 1 equals 0. So subtract 6x from both sides and then add 1. So now I have it in the correct form. I'm going to identify that my A is 2, my B is -6, and my C is 1 in terms of the using of the quadratic formula. And so now I'm going to plug it into x equals negative b. So negative 6 would be 6, right? The opposite of negative 6 is 6. Plus or minus the square root of b squared. Negative 6 times negative 6 is 36. Minus 4a times c, 2 times 1 times 2, all over 2a, which would be 4. Now comes the work of simplifying. So the first thing you want to simplify is the inside of the square root. So 36 minus 8 is 28. And the next thing you want to do is see if you can simplify this radical at all. So by simplifying the radical, what we're doing is we're breaking this into a perfect square times a non-perfect square. So that would be 4 times 7. And then we can take the square root of the 4, and that would come out front. So we are going to spend a little bit more time practicing simplifying radicals, but just in terms of simplifying under the square root, that's what you're looking for, is a perfect square times something else, and then you square root the perfect square and it comes out front. You leave the something else underneath. And now I've got a 6 and a 2. These are like two terms on top. I have a 6 here and a 2 root 7 there. I'm going to factor out what's common there, which would be a 2. So if I pull the 2 out of the top, now I have 3 plus or minus the square root of 7 left inside. And now I can cancel the 2 and the 4. I can't cancel here or here because these are terms, they're being added together. And you can't cancel things that are being added. But since this 2 is being multiplied by this other thing, I can cancel it with the 4. So I'll divide those both by 2. And that leaves me with 3 plus or minus the square root of 7 over 2 as my final answer. So do keep in mind that there are 2 answers, 3 plus the square root of 7 over 2, and 3 minus the square root of 7 over 2. Okay. So I could put the curly brackets around them to say this is a group of numbers that are the answers, but we just write it with the plus or minus notation here because it's a little more compact. But I want to make sure you realize that there are, in fact, 2 different answers to that problem.